Hello and welcome to another one of my thoughts videos. In this one we're going to be getting back to small planet theory again. A little bit more this time of where did all that water come from that covers our planet? It's a huge amount, and if we had a small planet like this size compared to this size, according to the Kola hole in Russia, there was water between 3 and 7 kilometres below the Earth's surface, and that could have been bigger once it had been non-fractured. So there was a certain amount of water that had accumulated under our crust when the planet was formed in the formation of our galaxy, and also a little bit of water leaking out onto the surface, and maybe even just accumulating on the surface of that small planet. But this huge amount of water that's on the present day planet, it couldn't fit on inside that little ball and on the surface, so it had to come from somewhere else. To understand that, we're going to have to go back to some basic chemistry. And I hope I won't bore you with high school chemistry, but a little bit more of interesting concepts behind the water on our planet. Now, the first concept that you're going to have to really understand and grapple with is the concept of attraction. Things attract, and often opposites attract. And this is how all matter in this world, and even non-matter, I'm not sure, but matter, how it all holds together. Now, this information we're very privileged to know. We are the second or third generation of people, and only the last 100 years we have actually known this information. A guy called Sir Lord Rutherford, who was born 6 kilometres from where I grew up, discovered that the universe was basically made out of protons, and protons have a positive charge, and the concept of attraction is that it will attract a neutron, and that will gain some sort of stability. And a smaller particle with virtually no mass is an electron that then orbits very fast around that little group here. Everything is made up of these protons, neutrons, and electrons, and the varying number of protons gives you the varying elements that the planet is made up of, the different atoms. One proton basically gives us a hydrogen atom, and there are lots and lots of those. It's probably one of the most common atoms, I think, in the universe because it's only got one proton. Now, that is what most of the suns and stars are made up of. It's just big balls of these one proton molecules all attracting to each other, compressing, and then emitting light. Now, the other very important element in the water is that it is not just one atom, a lot of atoms together. The sun that burns are mostly just these one atoms, but water is made up of 3 atoms. It has an oxygen atom and 2 hydrogen atoms, 2 of those plus an oxygen one. Now, when you have a hydrogen atom, you have 1 electron, but there is a space for another atom to orbit without them banging into each other. And if you have another hydrogen atom, it will have an orbit, an electron orbiting, and the space that is in this hydrogen atom is able to share this orbit space of this atom from this atom, and the space that is generated on this hydrogen atom can share the electron of the other one. So the two of them tend to stick together in 2 atoms, so that you have 2 hydrogen atoms together, and because they're sharing their space of the two electrons, one in this one in that one, sharing the space of each other, so they tend to group together and they're fairly stable. The oxygen atom here has, I think, 8 protons and it has 2 electrons in its inner ring, and then the next ring out, because you can only have 2 in the first one, there's another ring out that has up to 8. Now, because it has 2 on the inside, that gives you 2 plus 6 on the out, means that you've got another couple spaces. So the oxygen has 2 spaces that it can share, one here and one here. So it can link can bond, share a space from a hydrogen atom and into one of these spare spaces that the oxygen has, and another hydrogen that shares the other space, and then the molecule becomes stable. The water, these have a positive charge, and the oxygen therefore has a negative charge, I think it is. Or the other way around, can't remember. So that when you get another molecule of water close by, the positive, the nitrogen, the hydrogens will attract to the oxygen, and it keeps them in close proximity even though they don't bind, and that's why water clumps together. Now that's a very rough and ready explanation of basic atomic science. The proton, the neutron, electrons, one of those makes a hydrogen, and an oxygen has a lot more, and there's space on the oxygen to accept 2 hydrogens, and you get that sort of Mickey Mouse, the face with the 2 ears type of molecule, and they tend to attract to each other and glob together into water. Now that attraction is not too strong, and that's why water can evaporate, and with heat they will start to separate and fly away, and that's why water can be gas, liquid or solid when it freezes. So that attraction is not strong enough to make it permanently solid in a crystalline structure. But the interesting thing is that water in itself is not a single atom. So water basically doesn't occur naturally. It has to be assembled into a molecule out of the 2 hydrogens and 1 oxygen. And that's where the secret of where all that water came from comes. Due to that sort of law of attraction, the 2 nitrogen molecules, atoms, tend to stick together and are quite happy because they're now balanced with that shared electron, an electron space. Oxygens also, because they have 2 spaces, they also tend to share their 2 spaces and clump together. So even though you can get an oxygen and hydrogen as single atoms for chemical reactions and stuff, they tend to clump together so that they become stable and are happy in that state. So when you have water as a 3-atom molecule, then you need some active means of generating or disassembling this, and it applies to other things that we'll talk about in the future. They found out with the experiments with hydrogen production as a fuel that you can apply extra electrons to those gaps and fill those gaps, and that will separate the 2 hydrogens out from the oxygen by applying an extra oxygen to occupy those extra spaces, those 2 spaces on the oxygen and particularly on the hydrogen one, so that they now have 2 electrons, and they therefore don't bind. They have no binding sites, basically no spaces to share with the oxygen, and they come apart. Now the opposite is true, that you have to actually force the hydrogen and the oxygens together to get them to combine into the water molecule, because while there's 2 oxygens or 2 hydrogens together, they're quite happy just to stick together. And when you do separate these out using electrolysis for hydrogen production as a fuel, the hydrogens then tend to stick together, and the oxygens also stick together, and you can have the oxygens and the hydrogens floating in the same space, in the same recipient, without them converting back into water. What it takes to turn them back into water is those extra electrons, or in usually a catalytic event like heat, to speed the circulation of those until the molecules crash into each other, and they forcibly have to bang into each other and split, and that lets off energy as they combine. The extra electrons and things fly off, and that's how you can get your energy from it, and then you get that combination of the water molecule. So it has to be forcibly done because naturally they stay apart unless they're forced together to result in water. So all the water that's on the planet here, all the blue and the water that we drink and are made up of, are hydrogen and oxygen atoms that have been forcibly forced together into the water molecule. Before that, they were separated in hydrogen and oxygen, floating independently, quite happy to stick to themselves, to their own kind. And this is where the big secret is. Where did that water come from? I chewed this one over for years. I thought, was it ice particles? Was it this? Was it that? Was it water that floated up in a covering here? But no. I think the answer is that when the solids came together and attracted into that ball, some of the atoms, the hydrogen and oxygens that were forced together and became water as water, was trapped in that formation and underneath the crust and on the crust of that. And there was relatively little water compared to today on the surface and below the surface of the smaller planet. The majority of the water that we have, though, now was in the form of hydrogen and oxygen separated as a big cloud around the planet. We don't know how big, or I suppose you could get down and do the math and the calculations to find out how much gas you need to make a drop of water, then calculate how much water is here, and then extrapolate to find out how big that gas ball was around the planet. But the water was in the form of gas, hydrogen and oxygen, and they didn't mix because there was no catalyst. When our second sun went out, it went supernova, seemed like a big spark. That was the catalyst that then that forced those molecules together. They combined into water in a big sort of explosion, and that water then, because of gravity, started to fall onto the planet. As the small planet grew, the water also fell onto the planet and came to rest where it is now. Now that is where in the flood of Noah, the 40 days of rain came from. It says the fountains of the deep broke out, the water from below came out onto the surface, combined with that which was on the surface, and then the rain that took 40 days for it to rain down on the planet. Now, how much gravity do you need for that to happen is a good question. If you consider the space station where the astronauts float, they still, at that height, hundreds of kilometers above the surface of the planet, actually still have 80% of the gravity forces of the planet, even though they float. They don't float through lack of gravity. They float because they're actually in free fall. They're actually heading, because of the speed they're going, they're constantly trying to get away from the planet, but constantly falling towards the planet, to the point where they're falling around the planet. So when they're in constant free fall, everything floats at the same sort of floating ability. So at even 100 kilometers above the Earth, there's still enough gravity to make the rain, the water that then combined out of the hydrogen and oxygen, for it to then fall down onto the planet. So there's the big basic simple explanation, the short explanation, without getting into too much atomic physics and all of that. atoms made of protons, neutrons, and they have electrons orbiting. You have hydrogens, which one have a one proton at a neutron and electron. They generally stick together stable, and the oxygen having more, they're also stable. But if you get two of those hydrogens, one oxygen, you've got water, and they were as a big cloud of hydrogen and oxygen, and then with the extinction of our second sun going supernova, that created that spark to then ignite those two, force the two molecules together, the three molecules together, and then we formed water, which then fell onto the planet and then occupied the areas where the new part of the crust of the Earth formed, with the old part of the crust fracturing and moving to the positions that we have now. So that's where our water came from.